Hi everyone, in this video I'm going to walk through how to solve LeetCode 2485 find the pivot integer. As always, I'm going to do a full question breakdown, then we're going to visually walk through how we're going to solve it, and then we're going to write some code. So before I get into all of that, if you are serious about this kind of stuff, if you want to get better at data structures and algorithms and solving LeetCode style questions, then I would highly recommend checking out the first link in the description for the best course, the best resource on getting better at this kind of stuff. So let's get into the video. Basically, we have our question here. Given a positive integer n, find the pivot integer x such that the sum of all elements between 1 and x inclusively equals the sum of all elements between x and n inclusively. So then we return the pivot integer x, but if no such integer exists, then we're just going to return -1. And it is guaranteed that there will be a maximum of 1 pivot index for the input. So we have our examples here. So for 8, the output is 6. So that is because the sum of the numbers of 1 to 6, so 1, 2, 3, 4, 5, 6, equals the sum of the numbers from 6 to 8. And they both equal 21. And so it's important to take a look at this and recognize that, again, it is inclusive. So 6 is being added for both of these. So then if we take a look at the next one, for n equals 1, the output is 1, just because 1 equals 1. So, you know, the pivot is 1, and both sides of the pivot inclusively equal 1. Then the next one, n equals 4, the output is -1 because there is no such pivot integer. So now that we've read through this, it's time to actually think about it visually and think about how we're going to solve this. So I've got the example for 8 written out here. So for n equals 8, we have our numbers from 1 to 8 here, and we need to find the pivot in there. So we know for a fact that it is the pivot is 6, which means that the sum of these numbers here is equal to the sum of these numbers here. So we need to think about how we're actually going to kind of work out what this pivot integer is for any possible input. So the way we are going to do this is by kind of checking each number in the list and checking whether it's a pivot integer. So it's quite a simple approach. Basically, we're going to check for this our first element here. We're going to say, is this equal to this? And then if it's not, then we go to and have this is our pivot integer. And we go, is this equal to this? If it's not, then we check if this is our pivot integer, and so on and so forth until we either get to our pivot integer here and we go, is this equal to this? And it is, so would return 6. But if it wasn't, and we got all the way to the end here, and after 8, if we had not found a pivot integer, then we just return -1. So again, quite a simple algorithm here, not too super complex. So let's get into writing some code for it. So the way we're going to do it is we're going to go through and add all of our iterate through all of the numbers between 1 to n and add them to a list so we have all of them, and this is going to allow us to easily calculate the sums. So I'm going to initialize this list here, numbers equals empty list, and then I'm going to go through and create the list. So for I in range 1 to n plus 1. So this is going to go through I for every value from 1 to n. So this is exclusive, so it's going to stop when it reaches n plus 1. So it's going to go all the way up to n. And then I'm just going to append I. So cool. Now we have this list here. We have our list of all of the numbers from 1 to n. Now it's time to actually start testing some pivots and calculating some sums. So for pivot in range of n, so this is just going to, again, go through every single value in the list of numbers and check whether it is the pivot. So it's going to set each one as the pivot. Then we want to calculate the sum of the values before the pivot inclusively. So sum of the numbers from the start to pivot plus 1. So this is this final one is exclusive. So it's going to get the sum of all the numbers from this first element to the pivot. Then after pivot equals sum of numbers from the pivot. So this one is inclusive, and then to the end of the list. So this is how we're calculating the sum of the numbers before the pivot and the numbers after the pivot inclusively. And obviously if before pivot equals after pivot, then we're going to return the pivot plus 1. This is because this is the actual index of the numbers. So basically it's always the actual pivot value is always going to be 1 larger than the index. That's just because if you think about it over here, this has index 0, this has index 1, this has index 2. So we're just adding 1 to this to get the actual value of the pivot. So once you've done that, we need to have our default value, which is -1, which means it's gone through this and it hasn't found a single valid pivot. So this should run. This should work perfectly if I submit this, and that's great. However, we do want to make it more efficient, because if you think about this, now this is where we actually this is when you start thinking about the question and thinking about kind of different cases for it. So in what scenario, if you think about a list of numbers, and if we look at this one right here, it's almost guaranteed. Think about the largest number, 8. This equals 1, this equals 3, this equals 6, and then this equals 10. So I mean, for these first numbers here, they weren't even larger than the final value, let alone the sum of all the values after it. So this kind of pattern continues where we can just exclude a bunch of numbers, unless n is 1, then the pivot is never going to be 1, because these values after it are always going to be larger. So we can just start excluding a bunch of numbers. And if you think about it, I mean, I'm sure there's an actual proper mathematical kind of way to determine, how many we can disregard. But just for simplicity's sake, I'm going to cross out and not going to check the first half, because logically it's not really ever going to be in this first half. So what I can do here is start it at n, the integer n divided by 2, and go all the way to the end. So now if I submit this, so it's gone LeetCode's a little bit funny sometimes, and the runtime varies greatly. But basically, if you think about this logically, we're just basically not checking half of the values, so it should considerably improve our runtime and make it a lot faster. So that's a little optimization that you can make on our solution and still have it work perfectly. So that's everything. Thank you guys so much for watching. I hope this was helpful. Have a good one.